Let's look at three examples of arithmetic with rational expressions. The key here is to look for cancellations and factor everything in sight, and not just blindly proceed with the simplest seeming option. So here's a good example. We've got something I purposely made it look really awful. Um, if somebody just says, okay, multiply these two rational expressions, the most basic thing you could imagine is to just multiply the numerator here by the numerator here, and multiply the denominator here by the denominator here. In principle, that's going to give you a correct expression. It's going to be awful, and we really want to do something better. Okay, so the key is to factor everything and look for cancellations. They're not guaranteed to happen, but boy, it's pretty common. And when they do, it's much, much, much simpler. Okay, so let's just go back up to here and let's rewrite. Let's see. I'm going to go through the factorizations pretty quickly, but because it's kind of review. But let's see. Ooh, this one factors by grouping. That's 7q. I can take a 7q squared, sorry, out of the first two terms, and I get q minus 2, and then plus 3, and yay, I'm in luck, q minus 2, right? That doesn't have to happen, but it's great when it does. Okay, so in other words, it's just 7q squared plus 3 times q minus 2, factoring out that common factor. Okay, that's pretty cool. Okay, so that's progress. Okay, that's factoring that top of the left. The bottom is a difference of squares. Always good to recognize that. Okay, what's on the right-hand side? I'm trying to trot out a lot of things we want to recognize. Aha, that's a perfect square trinomial. You can recognize that by this is 5 squared and this is 2 times 5. Aha, that's good. Okay, and then the bottom, I've factored it already somewhat for you. This one, it's a sum. If anything, it's a sum of squares, and that doesn't factor. Now this guy, the 5 factors out, and so that becomes a 4. Ooh, now that's a difference of squares. Let me just go ahead and replace it. Q minus 2, Q plus 2. Okay. So if anything, it's taking just as much space or a tiny bit more on the page, but now we're going to get massive cancellations here. The 7q squared plus 3 exactly cancels the 7q squared plus 3. This q minus 2 cancels this q minus 2. Okay. One of the q plus 5s here, this is tricky. This is 2 q plus 5s multiplied together. This cancels one of those guys. Okay. So let's see. None of this survives, and only one factor q plus 5 survives. Wow. Okay. And now what have we canceled out? This has been gone away. And what's left? The q minus 5 here didn't cancel with anything. Okay. The q plus 5 has gone away. The 7q squared plus 3 has gone away. The 5 is still there. Let's put that in front. Simple before complicated is the usual rule. And then the q minus 2 did cancel here, but the q plus 2 lives. Okay. And that's about it. That's a pretty good way to write it. There's no further cancellations. And one thing, you almost never multiply out a denominator. If it's factored out, leave it that way. I think some people make the mistake of having you multiply those guys out. Leave it that way. It's much better to leave denominators factored. Okay, so that was really much, much better than it looked. Now, dividing fractions. There's different ways you're going to see this, but one way would be this. We'd have one fraction and then this division symbol dividing by another. Okay. The absolute key first step is to recognize that dividing by a fraction, you multiply by the reciprocal. There's various little ways to say that, but this is the most official way to say it. You multiply by the reciprocal. And that means you're going to multiply by the flipped version of this. Reciprocal of a fraction is just going to be exchanging numerator and denominator. Okay, so now it really turns it into the same problem. Let's go ahead and put an equals here. Okay, so that equals that. Okay, so as long as we understand that and you just do it really slowly and carefully, people often kind of double reverse that and end up reciprocaling twice and then you're not doing the right thing. But as long as you do that first, it really turns it into the first kind of problem. Now, once again, I want us to recognize some factorizations. Now here, there's a common factor of y here. Okay, and let's just do that. We're going to factorize that more, but I don't want to do too much in place. Once again, here, learn to look for those perfect square trinomials. Really wanted to harp on that. Okay, so we're going to get some partial cancellation already here. Let's go ahead and do that, just knowing that I still got something that cubic might well factor. Pretty similar to the first one. 2 factors y plus 6, only 1 here. So that's going to become a y plus 6 on the top and kill the entire y plus 6 down here and then have a y minus 1 down here. Okay. Now these look somewhat similar, don't they? Y cubed minus 1, y minus 1. Now just because of visual similarity, don't count on that. But we do know that difference of cubes factors. That does factor as exactly y minus 1. All right, and then the y squared plus y plus 1. So this is the one where the minus is here. You don't need any minuses over here. Okay, this is really nice. The entire denominator is going to cancel out. I'm just going to get y squared plus y plus 1, y plus 6. This isn't even a rational expression anymore. All of the denominator stuff actually has canceled. Again, I kind of contrive it to do that, but it's not uncommon that that's going to happen. So this is actually just a polynomial. Now, if I want to be really careful, I should have done this on the previous example. If I want to be super careful, there is a domain restriction here. This makes it look like you could put in any y in here, a polynomial. There's no division, so it seems like there's no y that would screw this up. But the domain restriction is anything that was in the original, like when I wrote it this way, anything that was in the original denominators is not going to be legal. So we would say, you know what, I really shouldn't say this is accurate for these two values. Okay, so sometimes I'm not going to worry too much about those domain restrictions, but it does turn out to be pretty important in some cases. But mainly, for everything but a couple values, this is simplified massively. Okay, next one. What about adding and subtracting? This is where, just like with fractions involving numbers, we want to find a common denominator. And again, it's all about factoring everything in sight. In particular, the denominators. The factoring the numerators isn't super important. And so I actually had the numerators be pretty simple. So let's see. Let me just do another copy there, and then I'm going to change it. Okay, y squared minus 4. Oh, that's supposed to be a y. That's a typo. Just kidding. I'm trying to be consistent with my variables. Okay, it's fixed. So another one, good one to stop and see if you know how to factor that. That's going to be y minus 1, y minus 3. Not a particularly hard one. And this one wasn't supposed to be too hard either. This is going to be y minus 3 and y plus 2. Okay. So you want to be confident with that. Okay. Now you probably want to see if there's any cancellations like top and bottom here or top and bottom here right now. There aren't. That would be a bit rare, but it's not impossible. So simplify as you go. Cancellations top and bottom are your priority when they exist. All right. Now what do we do here? Okay. So this is analogous to like if I had like 2/14 minus 4/21, right? There's a common factor here. That's, not 2/14. So let's switch them. You know what? There we go. Sorry. So 2/21 minus 5/14. There's a common factor of 7 here. And so sort of blindly, again, not a great way to do this would be to think the common denominator is just this times this. That's overly complicated. It would work, but it's going to give you an overly complicated answer because you're going to get 2 7s when you don't need both 7s. Yeah, so the key is we want the least common multiple of these two expressions. They share a y minus 3, so I don't just blindly multiply this whole thing by this whole thing. That gives me an extra factor of y minus 3 that I don't need. Okay, so the common denominator is going to be, let's just go ahead and start to put this in. I'm going to, what this doesn't have is it doesn't have a y plus 2. And so I'm going to go ahead and multiply it by y plus 2. And then over here, the only thing this doesn't have, to bulk it up to a common denominator, is it doesn't have the y minus 1. And I'll put it in front just to make it look identical. Okay, and so that's going to be y minus 1. It doesn't really matter which order, where you put it on the left or on the right. Okay, that looks a little intimidating, but now that the denominators are in common, I just copy this, and again, it's really very rare that you would want to multiply this out. Please leave it factored. Please leave it factored. How that's in the denominator, though. In the numerator, it's incredibly common that you are going to have like a product plus or minus a product, and you do need to expand each individual thing and recollect, because that you actually do get some simplifications a lot of time. So that's going to be y squared plus 5y plus 6. Well, that's not supposed to be an equals, though. Okay, because 3y plus 2y is 5y, 3 times 2 is 6. Okay, minus, and now here's a really easy thing to get wrong. This whole thing is going to be in a minus sign, so I need some really crucial parentheses. Okay, whatever this thing is, whether it's one term or 2 multiplied or anything, whatever that is, I want to put parentheses here, because that minus sign is going to need to distribute across all this whole thing. This is one group. That is the most common mistake I see in this particular business. All right, so this is the quantity y squared minus 3y plus 2. That's all getting subtracted. And the first thing I'm going to do is not do anything else but really, really carefully just distribute that minus sign. It just flips these guys. Okay, now I'm going to simplify the top by collecting terms. Just do that really, really carefully. Hey, that's interesting. The y squareds actually cancel, and that's not uncommon. Okay, and then I get an 8y plus 4. And that's not too bad. The denominator, yeah, it's gotten a little more complicated. That's totally what's going to happen. But the numerator actually turned out to simplify pretty nicely.